You eat bacteria for breakfast. Billions of them. Every spoonful of yogurt contains more living microorganisms than people on Earth. These aren't contamination. They're the point. Two bacterial species work together to transform liquid milk into something thick, tangy, and more nutritious than what you started with. How did humans figure out that letting milk spoil in exactly the right way creates one of the oldest health foods on the planet? Somewhere around 7,000 years ago, a nomadic herder in Central Asia made a mistake that changed breakfast forever. Milk stored in a pouch made from animal intestine didn't stay fresh, but it didn't rot either. The natural enzymes and bacteria living in that leather pouch transformed the liquid into something thicker, tangier, and surprisingly delicious. More importantly, it lasted far longer than fresh milk in the desert heat. The herder didn't understand the science, but he understood survival. That accidental discovery spread across ancient trade routes from Mongolia to the Mediterranean over thousands of years. The Turkish word yogurt comes from yogurmak, meaning to thicken or curdle. By the time ancient Greeks were eating oxygala with honey, fermented milk had become a dietary staple across 3 continents. The transformation happens through chemistry you can taste. Milk starts with a pH around 6.7, nearly neutral. Yogurt bacteria consume lactose, the natural sugar in milk, and excrete lactic acid as metabolic waste. As acid accumulates, pH drops steadily toward 4.6. This matters because of casein, the protein that makes milk white. Normally, casein proteins float as tiny particles called micelles, repelling each other through electrical charge. When pH hits 4.6, that charge disappears. The micelles stop pushing apart and start clumping together, forming a 3-dimensional protein mesh that traps water molecules inside. Liquid becomes gel. The process takes hours because it must happen gradually. Too fast, and the proteins would clump unevenly, creating lumpy yogurt instead of smooth. Here's what makes yogurt fermentation remarkable. It requires exactly 2 bacterial species working together in ways neither can achieve alone. Streptococcus thermophilus moves first, consuming lactose rapidly and producing lactic acid, formic acid, and carbon dioxide. But it can't break down milk proteins efficiently on its own. That's where Lactobacillus bulgaricus enters. This rod-shaped bacterium has powerful enzymes that shatter casein into peptides and amino acids. Those protein fragments become food for Streptococcus, which accelerates its acid production in response. Meanwhile, Lactobacillus feeds on the formic acid that Streptococcus produces. Neither bacterium thrives alone in milk. Together, they ferment faster and produce more complex flavors than either could separately. So if the same 2 bacteria make all yogurt, why does Greek yogurt have double the protein? The answer isn't better bacteria or special milk. It's subtraction. After fermentation completes, Greek yogurt gets strained through cloth or centrifuged to remove liquid whey. That watery yellowish fluid contains most of the lactose and dissolved minerals. What remains is concentrated protein and fat. For every 3 cups of regular yogurt you start with, straining yields roughly 1 cup of Greek. The other 2 cups become acid whey, a byproduct so acidic that disposing of it legally requires special handling. The thick, creamy texture you pay premium prices for creates an environmental puzzle the dairy industry still hasn't fully solved. Temperature determines everything in yogurt production. Commercial dairies first heat milk to around 180 degrees Fahrenheit for 30 minutes. This isn't just pasteurization. The heat denatures whey proteins, causing them to unfold and bond with casein micelle. This creates a tighter gel that holds more water and resists separation. Skip this step, and your yogurt weeps liquid within hours. After heating, the milk must cool to exactly 108 to 115 degrees Fahrenheit before adding cultures. Too hot, and you kill the bacteria. Too cold, and they become dormant. The fermentation window is narrow. Once inoculated, yogurt incubates at this temperature for 4 to 8 hours until acidity reaches the target pH. Every commercial yogurt maker guards their exact protocols as trade secrets. Here's what most people miss about live cultures. The bacteria don't just create texture and tang. They partially digest lactose during fermentation, which explains why many lactose-intolerant people can eat yogurt without experiencing digestive symptoms. They also produce acetaldehyde, the compound responsible for yogurt's distinctive sharp flavor. Different strains produce different amounts, which is why some yogurts taste tangier than others. The ratio of Streptococcus to Lactobacillus can range from 1:1 to 20:1, depending on whether manufacturers prioritize speed, flavor, or texture. By the time you open the container, billions of bacteria have completed their invisible work. In 1905, a Bulgarian medical student named Stamen Grigorov isolated the rod-shaped bacterium responsible for Bulgarian yogurt and named it Bacillus bulgaricus. Nobel laureate Ilya Mechnikov at the Pasteur Institute became convinced that these bacteria explained why Bulgarian peasants lived unusually long lives. He spent his final years promoting yogurt across Europe as a longevity secret. Modern science has complicated his claims, but the probiotic benefits of live cultures remain an active research area. What started as a preservation accident in animal skin pouches now represents a billion-dollar industry built on precise temperature control and bacterial partnerships. Next time you open a container of yogurt, you're looking at 7,000 years of fermentation knowledge. Two bacterial species that evolved to cooperate transformed milk from liquid to gel through nothing but acid and time. Casein proteins that once floated freely now form the mesh that gives yogurt its body. Every tangy bite contains the chemical signature of bacteria doing what they do best. They're not passengers, they're the process. So, which cultures are working in your fridge right now?